It used to take 3 people a whole day just to print off 1 page, but ICT has come a long way since then. Now you can print pages in seconds. You can even print 3D objects using stereolithography, but more on that later. Computer-aided design, known as CAD, is used to design and model products in both 2D and 3D. Computer-aided manufacture, or CAM, automates and standardizes manufacturing processes. Emmy is a designer. She also spends most of her free time inventing a robot to defend Earth from an attack from giant space crabs. She uses a CAD-CAM setup with input devices including a drawing tablet and scanner, and output devices including this 3D printer. Now, hit the switch to power up the system. The thing is, with a totally digital system, there's always a risk of losing your data in some bizarre accident, which is exactly why you'll have it all backed up on an external disk drive like this one. Emmy designs using CAD. Computer modelling in 3D involves 3 stages. First, you create a wire frame, where the design is represented as a simple mesh. It's quick to create and fast to manipulate. Go on, have a go. Next, you render the surface to give it a more realistic impression of the final design. Try out these fetching options. Finally, there's solid modelling. Pretty important when you're making an armoured robot. It allows you to evaluate the effects of changing the physical properties of your design, like its weight or strength. Run the test to model the robot's strength. Nice! After designing, the next step is making, which is where the 3D printer comes into play. Click to print in 3D. Instead of printing a flat image on a sheet of paper, Emmy's 3D printer makes solid objects. It's like assembling a loaf of bread from its slices. Software slices the imported CAD design into lots of thin cross-sections. The printer then prints those cross-sections one at a time. Instead of paper, each slice is printed into a thin layer of powdered plastic, and in place of ink, they use heat or chemicals to fuse the powder into a solid. The process is repeated for every layer until you have a complete 3D object. Right, the robot's finished, but before it faces an army of space crabs, it needs proper evaluation. Evaluation means testing a product to see if it meets the design needs and is fit for purpose, finding its strengths and weaknesses and seeing how it could be improved. Exactly how you evaluate a product depends on what it is, but here are some of the main things you might test. Firstly, form. The form is the shape and dimensions of the product. Next, materials. Are they appropriate? For example, how easy are they to dispose of without harming the environment? Sometimes looks can be important. Many products rely on their aesthetics to enhance their appeal. It's important how a product fits and feels in the hands of its intended users. For example, the robot's remote control needs to feel just right. Go on, give it a try. And finally, how does the product perform the task it was designed for? Which is difficult to test without an actual invasion of space crabs. Product evaluation requires level-headed critical judgment. There might be elements that work, even if others don't. So, let's face it, there probably won't be an invasion of space crabs, but there are still features that could be useful, like the laser beam. Click to give it a blast. That could be useful. Probably.